right, my friends, welcome back to some more u sub. So this is part D. We're going to be doing some problems with e to the u or 1 over u today, looking at a couple more like that. So let me give a few examples here. So suppose we have integral e to the 10x plus 1. Now, none of the problems today are going to use any necessarily new strategies. We're still doing a u sub, just looking at different contexts. So when you look at something like this, you should look at this and think, okay, what is up in my power? Like the 10x plus 1 is in parentheses. So that's what you want to pick u to be. So I'm going to pick u to equal 10x plus 1. All right, well, the derivative of that is just 10 times just 10 and then dx. So we put a 10 here, we put a 1/10 in front. That's a constant, so I can do that. So this is 1/10 integral e to the u du. So that's just 1/10 e to the u plus c. Which is 1/10 times e to the 10x plus 1 plus c. Okay, and again, if I take a derivative in my head, okay, e to the 10x plus 1 times 10, the 10 and the 1/10 cancel. Yeah, we're back there. That sounds good to me. Cool. Okay, let's look at a couple others. So one of the ones I see people bollocks a lot of times is if you have dx over e to the 3x. Like, if you do this with a natural log, God help you, I will destroy you and hunt you down for the rest of your days. What you want to do is just rewrite this. So rewrite this as integral of, so rewrite it as a positive exponent, a negative exponent, without the fraction. So write it as e to the negative 3x dx. Like, that's how you want to do it. And then you're like, oh yeah, cool, I have e to a power. So u equals negative 3x. So the derivative of that's just a negative 3 dx. And then we're chilling, right? We put a negative 3 here. We balance the negative 1/3 in front. So then this just becomes negative 1/3 integral e to the u du, which is just negative 1/3 e to the negative 3x plus c. I should have shortcut. That's negative 1/3 e to the u plus c, and then I plug back in for the u there. Okay. So that's how you do this type of problem. It also shows up, here's another one, like you'll see integrate e to the x raised to the 4th power. Don't try and do any kind of like e to the x over 5 divided by 5 shenanigans. That will only end in pain and suffering. Rewrite this. Right? Try and simplify first. That's always a good general rule. Can I simplify what I have first to make it an easier problem? So let's turn this into the integral of power to power is just e to the 4x. And then you're like, oh yeah, u is 4x, du is 4 dx. Cool. 4 1/4, so it's 1/4 integral e to the u du. And again, all these problems with e are great because the integral e to the u is just e to the u. So you just have that constant just stays in front. So this just becomes 1/4 e to the 4x plus c. Terrific. Okay, so let's get to another strategy here. So let's suppose we have to integrate 2 dy over 8y plus 3. Here's a trick worth knowing. If you have a fraction and you're not sure what to pick for your u, try this. Try to set u equal to the denominator of that fraction. So try to set u to just equal 8y plus 3. Okay, I'll take the 2 and move it in front. So then the du is just 8 dy. So let's see. So this is 2 times integral dy over 8y plus 3. I should have moved the constant in front. So now when I do this, I'll need to put an 8 for the 8 dy. Again, I need to match up my constants as always. So I need 8 there and a 1/8 in front. The 1/8 times a 2 is going to be 1/4. 8 dy is du over u. So that just becomes 1/4 ln of absolute u plus c. So that just becomes 1/4 ln of 8y plus 3 plus c. Okay, so that's a good strategy to use with fractions. One more thing that's a good one, like here's the integral of cotangent of x. Now you might look at that and be like, bruh, how would a u sub be at all useful with cotangent of x? Like, does u equals x? That doesn't make any sense, right? U equals x is something I'll never do. But again, let's see if we can rewrite this. So what if I rewrite this as the integral? Okay, cotangent, I know that's just cosine over sine. And now let's try this trick where we try the u to be the denominator. Try u to equal sine of x. Well, then the derivative of that is cosine x. Oh, we have a cosine x dx. Oh. Okay, so the cosine x dx just becomes a du, and then I just have a 1 over u. I have the sine x, that's a u on bottom. Okay, and that's just ln of u plus c, which is just ln of sine of x plus c. Okay, and if you take a derivative, it's 1 over sine times cosine, it works out, and that, my friends, is how you integrate cotangent, right? You just write it with cosine and sine and do a u sub. So these are just some more examples of where a u sub can be really useful. Again, like I said in the last video, get some practice with these. Try and do these problems on your own, and then the more you do of your homework, the better you're going to get. This turns out to be a really powerful strategy. All right, thanks for watching, and I'll see you guys in class.